All right. So 11.2. Today we are simplifying radicals.
I went to go like this and it catapulted.
There you go. All right. Simplifying radicals. Okay. So how to do that? Step 1. And y'all need to write this down. See? Without Drew, I can see everything. Okay. I'm just playing with you back there. All right. The first thing you're going to do is write the radicand. Remember yesterday we talked about that. That's the number that's inside the radical sign, the square root looking deal, as the product. What is product?
Answer to a multiplication.
That's right. Answer to a multiplication problem of its prime factors. So first, write this down. Write the radicand as the product of its prime factors. Blah, blah, blah. You are doing a factor tree. So if you remember when we looked for like the GCF and everything, we did of like multiple numbers, we did the factor tree, and then we wrote out all the prime factors by multiplying. Okay, that's what it means by the product. Okay, number 2. Apply the product property to the perfect powers. And what this is saying is the square root of xy would be written like this. But I'm going to show y'all something a little different. Make it a little bit easier. Like I said, if I can get 7th grade on board, I can get y'all.
What they've been through this morning?
No,
This was this morning.
Yeah, no, me teaching them this whole chapter was like last week and everything.
Is that an A or an N?
These are ends.
Okay.
Good question. Those are those words. That could be any number, like 2, 3, 4, whatever. See, 7th grade only deals with squares, root of 2. The only difference between y'all and 7th grade pre-algebra is that y'all are dealing with just higher number of roots. That's it. This is why it's actually kind of okay that in the past they've skipped this chapter, but hey, I think it's good for them. Step 3, simplify the roots of the perfect powers. And I'll explain that. And then step 4, multiply the factors inside and outside the radical. So inside and outside of the radical. That's what they mean. When you're done copying the notes, put your pencil down so I know that you are done. Are you done? You sure? Okay. All right. So here we go. First example. Y'all are going to probably get it almost immediately. Perfect for a quote Friday. Okay, so we're going to simplify this. Now, first thing, is this a perfect square?
Yes.
Okay, Morgan. What number times itself gives you 18?
I realized my mistake.
Okay.
But I was gonna let you finish your sentence before I finished.
So is this a perfect square? Is there any number that times itself will give you 18?
No.
No. That's why we're going to simplify. All right, so the first thing you need to remember, especially for Algebra 1, is the root. You need to first notice the root. Is there a root here? That's right. There's no number here, so we assume it's 2. So the root is 2. You need to stay focused on that. So what you're going to do is find all groups of 2. And I don't mean the number 2, I mean pairs. Keith wrote that down. All right, so back up here, number 1 says factor tree. So we're going to take 18 and we're going to do a factor tree of 18. What two numbers give me 18 when multiplied, Franz?
2 and 9.
2 times 9. 2 is prime. And then we know 3 times 3 gives us 9. Okay, so I'm going to write and cross out each of my prime factors, and so are you. You're writing this down.
Stay back.
Right?
Oh, she's not so mad.
What? I am writing.
All right. The root is 2. So you're going to circle all your pairs. And you're going to underline your leftover. Your pairs go on the outside, and you only write one representative of your pair. So only 1 3 goes on the outside. Your leftover goes on the inside. That's a weird arrow.
Is this the answer?
And that's your answer. That's it. So when simplifying, do your factor tree. Write out your prime factors in order. If the root is 2, then you're going to find all the groups of 2, or your pairs. Here's a group right here. Then one number representing that pair goes on the outside of the radical sign. Your leftover goes on the inside. There's your answer. That's simplifying it. Any questions? Yes?
The leftover is more than 2 is it plus 4 times?
You mean if there's more numbers than 2?
Yeah.
Okay, that would be 4. You're going to multiply the factors on the inside and outside. So let's say I have more than just a 3 here. You would multiply those together. If I had more prime factors on the inside, I would multiply them together. Any questions so far?
So does that mean that 3 times the square root of 2 gives you 18?
Yep. If you did it on a calculator, it would work out. Any number that's on the outside, if you square it and then multiply it by on the inside, you get 18. Because 3 squared is 9. 9 times 2 is 18.
Wait, why would you square it then?
Because remember, okay, because right here, see there's 2 3s?
Right.
So only one went on the outside.
Okay, so
That's basically saying, like if we were to multiply this and that would be 9, that would be like saying 2 times 9. Oh, look, there's a perfect square. That's 3, right?
yes.
Okay, let's do another. Telling you, the more I do these, the better y'all get. Keith, quit doing their helicopter thing back there. Making me crazy. Do that. And,
It's still like you.
who's sitting still? Oh, shake your leg or something. That's what dogs do when they're nervous or something. They shake.
Do I look like a
No,
dog?
but you're twirling around. Your ruler is distracting to me, and I don't like it. It's my classroom, my way or the highway. All right, let's do this one. 24. All right. So again, and keep in mind the reason I'm saying keep an eye on the roots is because the root we're about to go into 3. So if there's no root here, what do we pretend it is? 2. So then our root is 2. So then we're looking, finding groups of 2. I'm writing this for your notes. You should be writing it 2. You don't have to do it on your actual work. Okay, so first step is to do a factor tree. What 2 numbers give me 24, Sophia? Okay. 2 times 12. What 2 numbers give me 12, Miranda? 2 times 6. And this would be 2 times 3. So we're circling only our primes. We've done this before. Now we list. I'm going to write them here. No, I'm going to write them down here. And remember, I taught y'all to cross them out so you don't get confused or leave any behind. Now, back here it said your root was 2, so we're going to circle groups of 2. I only have one group of 2, but I have 2 leftovers. So my group of 2 goes on the outside. My leftovers go on the inside.
Do you multiply them?
How many 2s do I write on the outside, Franz?
1.
Very good. And then my leftovers are going to go inside the radical. And yes, we multiply them.
Be 6.
That's right. So your answer is 2 times square root of 6. And there you go. Any questions? Not bad, right?
No.
All right, let's do another. I'll wait till everyone has us down.
Do Q. Q.
Let's see. Look, I'm even going to skip an example. Let's do 288.
That's a big jump.
All right, so what's my root? That's first thing.
2.
So my root is 2. We're going to be looking for pairs of 2. So we start with our factor tree.
2 and 144.
Very good. 2 times 144.
Circle 2.
Mm-hmm.
And then 12 times 12.
Oh, very good.
And then for one of the 12s is 3 and 4.
Okay, 3 times 4.
And same for the other one.
And same for the other one. And y'all can choose any numbers as long as,
Circle the 3s. And then simplify the 2s to just 2 and 2. The 4s to 2 and 2.
Yep. Very good. All right, so this time we have a lot of prime numbers. So make sure you write them down. List them in order and cross out as you do it. So you don't do too many or not enough.
Groups.
Okay, Valeria, how many, what am I circling? Groups of what? Okay, so let's start circling. I have a group here. Do I have any others, Valeria?
No.
What about right here?
Oh, three.
Yeah. There's a pair, and there's a pair. And then I have just one left over here.
And then you put it into
So then, what do I put on the outside, Valeria?
2.
Just 1, 2? Just that? What else? Fine, stop. Look at these pairs. Each of these pairs are going to go on the outside. Do what?
3.
And I have 2 groups of 2, so I need to put a representative from all of that. So I have a 2, and then another 2 from that pair, and a 3. Do you see that? And then my leftover is going to go on the inside. And we're multiplying all of these, so 2 times 3 times 2 is what, Franz?
12.
So my answer is 12 times square root of 2. Okay, do y'all have any questions? Make sure that you circle all of the pairs. If your root is 2, then you're circling all of your pairs. And 1 from each pair has to go on the outside. And then all of your leftovers go on the inside. In this case, we only had 1. Up here, we had more than 1, so we had to put them in there and multiply. However many you put on the inside, you multiply. However many you put on the outside, you multiply. Everyone understand? All right, let's do another. Do you have this down, Valeria? Okay. What about this? All right, so this time, what is my root, Sophia?
3.
That's right. This time my root is 3. So guess what? I'm finding groups of what? That's right. Before I was finding pairs, groups of 2. Now I'm finding groups of 3. So we do a factor tree.
It's still the same.
Morgan. What 2 numbers?
5 times 27.
Very good. 5 is my prime.
Then 3 times 9 and 3 times 6.
Very good. All right, so we write out all of our factors in order. And this time, because of my root of 3, I'm going to circle my groups of 3 this time. And there's my leftover. So then I need a representative from my group that I circled, and that's on the outside, and then the leftover goes on the inside. So how many 3s do I need, Miranda? 1 goes on the outside, and my leftover goes on the inside. But see this little 3 here, this root? You better put that in your answer or it's wrong. Miranda, you have a question? No. If they, okay, let's say this said root of 3. She had a good question. Root of 3, but we didn't have any groups of 3 to circle.
Then it'd be a perfect.
Then it would be probably simplified already. Or it could be, if you want to know what the perfect, if one of the questions in 7th grade is, what if there were no leftovers? That will be your perfect cube. The number would just be on the outside. This part would be gone.
So you wouldn't have the actual numbers.
If you, like, let's say we had 3 5s here. So I circled my 3s and my 5s. Then the 3 and the 5 would go out here. There's no leftovers to go on the inside. So there is no inside then. This goes away. You just do 3 times 5, 15. That's your answer.
So would that be a perfect cube or no?
I believe that means it would be. So like here, if they didn't have any group of 3 and your root is 3, then it's simplified. There's nothing else you can do. It's already simplified. So that would be your answer.
Anything in the middle, like in a.
No, if there were no groups of 3 and your root is 3, this is your answer. You cannot simplify. Because remember, we're just simplifying it. All right. Any questions on that? All right. Open up your book. We're doing examples, page 439. I think we've done enough that y'all kind of get it. I'm going to show you the examples that I'm going to do are going to be with variables.
I have one thing.
Mm-hmm.
For one of the questions, number 2, it's the exact same as one of the ones that we've already done.
Okay, so what's your question?
So that's the whole thing.
Well, what's your question?
Um,
Okay. So we're going to jump all the way to 25. So again, keep in mind, if you had a problem like this, you did the factor tree and there is nothing that you can circle, then it can't be simplified anymore. It's already done. Does that make sense? Okay. So 25. This has variables.
wait, we're hopping right into 25.
Yes. Okay. Ariel. And those are 3s, by the way. What is my root?
2.
That's right. Since there's nothing there, the root is 2. So, Ariel, we're going to be finding groups of.
2.
That's right. Okay, so in this case, this is just like when we did greatest common factor and everything. We're going to focus on the number first. Okay? All right, so Ariel, what 2 numbers give me 50?
2 and 25.
Good. And then, of course, we have 5 and 5. All right, so now I'm going to write down my prime factors. And I'm going to include this time my variables. Ariel, how many x's do I have here? That's right. 1, 2, 3. How many y's do I have, Ariel?
3.
1, 2, 3. Okay, so Ariel, I've written down my prime factors and my variables. What am I circling? Groups of what?
2.
So here's a pair, here's a pair, and here's a pair. So what are my leftovers, Ariel?
2, X and Y.
Perfect. So Valeria, what's going to go on the outside?
5XY.
Perfect. 5xy. 1 of each. goes on the outside. And then what goes on the inside, Valeria?
The leftovers. See, that's why.
And there's my answer. So my answer is 5xy times square root of 2xy. And the root was 2. So we don't have to write a 2 here in the little check thingy. It's not wrong if you do. And there you are. Any questions? None? Miranda, you good? Is everyone done writing? I'll wait, Valeria, let me know when you're done, okay? You got it? Does anyone have questions before I do the next one?
I just don't like the wrong for that one.
Okay, good. 29. Square root of 75 times a cubed bc to the 8th. Extend that. Miranda, what's my root? That's right. So we're going to be looking for groups of 2. So let's start with the factor tree. What 2 numbers give me 75?
5 and 15.
Perfect. 5 times 15. And of course that's 3 times 5. So we write out our prime factors. And then, Miranda, how many A's do I have? We start on variables.
3. Or 17.
No, that's 3. How many B's do I have?
4.
And then how many C's?
8.
1, 2, 3, 4, 5, 6, 7, 8. You are going to get to where you don't have to actually write down every variable. You can kind of figure it out in your brain, but for notes, I'm writing it out. So Miranda, how many, I'm looking for groups of what? 2, that's right. I have a group of 5s. A's, do I have any groups of B's? And then I have 1, 2, 3, 4 groups of C's. So, Miranda, what goes on the outside?
5 A C times C times C times C. Or not just once. Or no.
How many C's do I have?
4.
So then, there you go. You don't, in this situation, you really don't have to say 5 times A times C times C times C. You can just write it with an exponent. Then that, see, there's 4, 1, 2, 3, 4 groups. So just write, exponent of 4. So what goes on the inside?
3B.
Do I need to put anything in my little check thingy? You're correct. Any question? I'm going to do one more, then I'll set you free. Does everyone have this? All right, look at 33. This one has a root of 3 with 15, x squared, and then y times z squared. Okay, so Franz, what's my root?
The root is 3.
All right, so I'm going to start on my factor tree.
And that would be 3 and 5. 3 times 5 equals 15. Straightforward.
And then that's it. So then let's write it out. 3 times 5.
Okay.
How many x's do I have?
2,
How many y's?
1,
And how many z's?
2,
What am I circling? Groups of
3. So nothing.
bingo. You're supposed to be circling groups of 3. I don't have any.
So really, that's just the answer.
This one basically is already simplified. The answer that the book is wanting you to say is can't be simplified.
You just say the.
Because basically it already is simplified. Now, if I had 3 z's, let's say I had 3 z's, there'd be at least one group, and it would go on the outside, and then everything else would be on the inside. Does that make sense? Miranda, does that make sense? Any questions? All right, so y'all are going to be doing page 439.
Okay. No 440.
Numbers
2 and 6, and then 18 to 26.
2 through 32 even. That's like 16 problems. Honors does 6 through 32 even. And 42 and 44. This will be due Monday. I'm going to attempt to put IXL, assign some. It's going to be due Friday.
Next Friday, not this Friday.
Well, then we won't be here tomorrow.